Hello and welcome. I want to start with a quick programming update on the channel. I know I've been quite busy lately, but now it's going to go even crazier because yesterday, I'm recording this on Sunday morning, yesterday, Saturday, was the casiest day in the history of cases because there were uh, three local chapter finals and another local chapter first round. So in total, 12 new cases, five from Brazil, four from Dach, and three from Madagascar. Um, if this was an otherwise quiet time, I think that that kind of glut of new stuff would gradually get absorbed and people would kind of cover it all. But we're like 1 week away from the qualifier rounds, and then, not much further away from the knockouts. Um, and so I think there's a good chance that if these don't get covered quite soon, that they will not ever end up having video walkthroughs. So I am going to attempt to make a video on all 12 of those cases and in general to keep up with the new cases coming out. Uh, if I can, no promises. But so you're probably going to see a daily video from me, aiming for a video at 11 a.m. Eastern time, New York time, every day until I catch up on the madness. Because I'm going to be playing them anyway. But it will probably also mean that my videos will be, not that they're ever very edited and thoughtful, but I often, go back and add a few minutes at the end where I figure out what I did wrong or something like that. I'm not even sure I'm going to do that for this stuff. But anyway, lots of cases coming up. But I had to bump this one to the top of the list. This one is called Who's There? And if you think that what I'm about to describe is related to a popular board game called Guess Who that I might have seen my children playing this summer, then for legal purposes I could not possibly comment. But this is one of my cases that appeared in one of the semifinals of the Brazil competition yesterday. And, oh, I think it's like Othello all over again. I heard from multiple people, including Gabe, who I think got the top score on this case, that the winning strategy on the day was to do it manually. And I did worry with the setup that it was a little on the guessable side, but I went with it anyway. I still think formulas are the best way to do it, but yeah. So I was asked, is there a way to do this right? And there is, or at least there was meant to be. So I'm going to attempt to demonstrate that now. So let's start the timer. This case is based on a game of deductions. There is a list of people with different attributes, hair or eye color, wearing a hat, scarf, glasses, etc. For the initial levels, there are 24 people with a smaller list of attributes. Later, we'll deal with a list of 1,000 people. One person is selected at random from the list, and the player has to work out who it is by asking a series of yes-no questions, e.g., does this person have blue eyes, and eliminating options based on the answers. So if we just go over to the small tab for a minute, you might ask, I don't know, does your person have blonde hair? And the answer could be no. And then you might ask, do they have blue eyes? And the answer might be yes. And then you might ask, do they have a beard? And the answer might be no. And you might ask, do they have a hat? And the answer might be yes. And you'd say, okay, I know who it is. It's Maya. That's the idea. But then over here we've got a list of 1,000 people just to make it a little more, complex than what my 7 and 9-year-old children are dealing with. So let's right away name this as small, table design, small, and I don't know why it doesn't bring the focus back to the grid after you've hit enter to commit a table name here, but anyway, large. They're probably bad names to give to a table actually, because they're function names, so they're also more characters than I like to type for table names, so let's make them SM and LG instead. Okay. 1 minute spent on thinking about the right table names. I have got to be on winner here. Okay, what color are this person's eyes? Use the small data tab. So we're just going to XLOOKUP this in small name, returning from small eyes. That's right. I guess I should dwell on the data just a little bit more. So you got a mix of, there's gender, which is just male and female here. There's also non-binary on the big one. You got hair, which is just one of 4 colors here, but on the big one, you can be bald, or you can be a mix of like wavy, curly, straight, short, long, and a color. Eyes, just more options for color here. Skin, there's a few different options for color. There's expression, a few different options, and then there's also on each one of them, there's a bunch of things that are just yes, no. It's like glasses, beard, mustache, smiling, facial piercing. I don't know why I put in smiling and also expression, because I'm pretty sure some of these, yeah, look, this person looks sad, but they're smiling. I guess that's possible, but that was kind of stupid. Anyway, whatever. Okay, does this person have this attribute? Use the data on the small tab. And hint, for this level, we're only looking at yes, no attributes. So I'm gonna, oh, I don't have my lambdas actually, so let me import my lambdas. Just for convenience, I will say my original solve of this case was completely without lambdas. It is possible, but that's not what I'm mostly focused on right now. So this is just an index match shortcut. So we're going to look up that, and actually we can give this ranges. So we're going to look up these people and these attributes and return yes or no. Okay. Level 3, answer the given question about the given person. Use the data on the small tab. Hints, all questions contain the name of a column in the data set, except is your person male and is your person female, which both relate to the gender column. For yes/no questions, the answer should be the value in that column for that person. For others, gender, hair, eyes, etc., it should be yes if the given description applies and no otherwise. Don't forget that the word female contains the word male, so you do have to watch out for that. Okay. So all the example 3 questions are based on Isla, not sure, let's go with Isla, who's described as female with blonde hair, hazel eyes, and a scarf, but no beard, mustache, hat, or necklace. So is your person female? Yes. Does your person have blue eyes? No. Does your person have a hat? No. Does your person have a scarf? Yes. All right. So I think this is where the difficulty ramped up for most people. And you know, basically, if you can kind of get this to work, it's then the same thing for the large data set, and then it's the same kind of idea, just not in the form of a question, but attribute lists that you need to handle. So in my mind, the key to solving this case by formula is being able to turn one of these questions or one of these attributes down here into a sort of an array of ones and zeros of the size of the table. In other words, whatever, does your person have green eyes should turn into 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, etc. So first thing we want to do is figure out what column are we dealing with. And there's a few different ways you can do that. My original solution was pretty regex heavy, but I suppose now that I know how many people felt they had to do this manually, I feel like I want to demonstrate something slightly more approachable. So I'm going to try and do something that will work for large right off the bat. So I'm going to take this longer list of attributes. I'm going to make a lookup table. Just name that LU. Okay. So basically, if any of these appears in the question, then that's the column it relates to, because it specifically says the column name always appears except for male and female. And I'll just look ahead to number 4. From once we get into the large data set, there's also a question, is your person bald or is your person non-binary? So those are the 2 other questions that might not contain the name. So I'm just going to add to here male, female, non-binary, and bald. And then each of these relates to that column, and then those relate to gender, and this relates to hair. Okay, so related column. So I'm going to call this, I guess, desk and call. So what I want to do is search. Oops. Hang on. Actually, yeah. So I'm realizing that I'm going to run into the, if I search for male, it will match in female also. But actually, that's not a problem, because in this case, sorry, if I search for, yeah. So, sorry, let me finish the sentence. That's not a problem here, because I just want to identify what column it relates to, and male and female both relate to the gender column. So I'm going to search my description within here. Sorry, not within there, because it's actually over here. And most of those are values, one of them is not. So then I'm going to say is number of that, and then we're going to XLOOKUP true in that, returning from whatever I called it, col. Okay, so this is the column that it relates to, and we can kind of copy that down. Yeah. And then, well, then we can TLOOKUP in small all for this person and this gender, sorry, and this column, I mean. And then the one thing you just have to be a little careful about is male. So in other words, if this question was female, and you said, does it contain the word male, then the answer would be yes. I feel like I had a cleverer way than is coming to me right now to deal with that, but so I'm going to say if this equals gender, then I'm going to say text after this, substitute, sorry, text after, substitute that. Get the question mark out. Do I have to put in a tilde? No, I think it's search that takes wildcards, but not substitute. So text after that, after that, after -1. Sorry, let's just take this out for a second. Good. Okay. So then, if it's gender, I just want to test that equals that. And then otherwise, I want to say is number search this in this. And then I want to say if all of that, then yes, otherwise no. Wait, sorry. Hang on. So need to start with something more basic because this is not going to work on the hat exam, on the binary yes/no question examples, because in this case I'm not looking for the word no. So for the columns that have descriptions, I'm looking for those words in the thing. But for the columns that have yeses and nos, I'm just looking to match, is it yes or no? Well, I'm just looking to return the yes or no here. So let's try one more thing. We're going to say if or this equals yes, no, then just give me that. Otherwise, give me all this stuff. Okay, so now I match the examples, and hopefully that's enough. Yes, hooray. Okay. So now hopefully it's kind of the same thing here. Oh no, sorry, slightly different thing here. How many people in the large data set would get a yes answer to these questions? So how many people would be a yes to is your person smiling? So some similarities and some differences here. First thing I do still want is to figure out what column it relates to. So I'm looking at smiling. And then. Okay, so again, for the yeses and nos, we're now just done, right? If it's a yes/no column, then that's just the answer. But if it's one of these, here is extra complicated. I'll come back to that. But for any of these, I just have to search. I just have to say, is this text contained in that? For this one, I need to also consider it could be either of the two words. So one way to do that is I can say TLOOKUP. Sorry. Yeah, no, I can still do that. So SM, I was thinking about having a name, but I don't have to have a name. I can just do a column lookup. Huh? Oh, sorry. Yeah, because we're not in SM anymore, and SM does not have a smiling column. There we go. And this one is much larger, but there it is. Okay. So I guess one thing to check is, so the first 6 columns are the name and then 5 things with descriptions, and everything from then on is a binary yes, no. So we're just going to say X match this against LG headers, and then, well, let's just, so if it's, if this number is 7 or greater, then we can just count the yeses. Well, I guess, yeah, let's just do that. So this, I think this will give me, I can't remember if lookup is countifs compatible. Let's try. That is not what I was expecting. Yeah, just lots of value errors. Okay, fine. So then let's just do sum of minus minus. This equals yes. Okay, so that matches the 515 there, but now let's go on. So for the non-yes nos, the first 5, I basically want to figure out, does one of these exact words, and exact words not just the text because of the male-female split, oops, sorry, does one of these exact words appear in here? So I think this is, again, not exactly the way I did it before. I was more regex heavy before, but I'm going to split this on space. What am I doing? Array constant, space, and question mark, and ignore empty. And then I'm going to so I was about to think I would split the column, but that was because I was thinking of one thingy thing, of one, where are my words? Of one person, but what I want to deal with is the whole column. So I'm going to have to split here into 2 words. So let's figure out how to do that. So again, I'll just come out here, have some space, say tlookup LG all the row value I'll leave blank, the column value will be this, but I don't want to do it for smiling because that's just a yes no column. So let's go here. Okay, so sorry, let's not go there, let's go on down to a here one. There we go, because this is where it gets most complicated. So what I want to do is text before this, before a space, if not found, no, sorry, match end. That'll give me the first word, and then I want to do text after this, after a space, match end. That's not what I want. I'm never totally sure how the match end thing works, but so what I want is for it to give me bold, if it's bold, so that there is at least a word there. So I'm going to say text after space and that after the last space. So now, basically, I can say if this word or this word appears in there, then it's a yes. Otherwise, it's a no. But if I apply that same logic to a column that only has one word in it, then it'll just repeat the word twice, and it's kind of no harm done. Okay. So I want to say this. Well, let's take this in here, I guess. Is it time? It's probably time to start building a let. This is getting hairy. So okay, let's say let CL be that. Let CL num be xmatch CL against the headers. Then we're going to say if CL num is greater than 6, then that. Otherwise, we go on. I guess I'm doing this tlookup twice, which is not super efficient, but I don't really care. Otherwise, we're going to say sorry, I guess let's carry on here with some other things. Words can be text split of this on space and question mark, ignoring empty. And then I guess we can take this, call text, can be that. Wait, sorry. Then call first can be text before call text, space, match to the end. Call second can be text after that and call text after space. Okay. So then I want by row call first lambda row or row equals, wait, sorry. Yeah, no, because the row is just one value. So yes, sorry. I was worried about broadcasting because I was thinking of two words, but the two words are done separately. So sorry, or row equals words. Then I guess we can say plus. No, let's not say plus. Well, yeah, let's say plus. Same thing applied to the second column. Call second. And then we want to know if that, so basically does either of the words appear? So we're saying is that greater than or equal to 0? And then we want sum of minus minus of all that. In A, oh dear. All right, so let's name this out. And let's come to the end. So where are we going wrong? We got words working okay. Yes, but we're in the wrong place, or in a place without space, fine. Then have we got call text working okay? Yes. Call first and call second, presumably also working okay. Oh, not auto-completing. Why not? That's usually a bad sign. Oh no, it's just that in the way. Okay, never mind. Ah, okay, there you go. I said match to end. Oh no, I said match mode. Whoops. Okay, that's better. How about out now? 1000. Oh dear, that's not good. Which one are we doing? We're doing hair. Pink hair. Okay. So, and actually, I just realized we could just do by call first equals words, and then actually we could put it together even more. So we could say hstack call first equals words, call second equals words, and then by row all of that just with or. And then there'd be no need for plus the second one. Okay, so I was doing something silly along the way there, but anyway, whatever, doesn't matter. Oh yeah, I said greater than or equal to 0. That should have been greater than 0, and then it would have been 15 anyway. But okay, shoot, now I've got rid of the nicer version. Stupid. Right, fine. Bring the nicer version back. hstack call first equals words with call second equals words, and then by row all of that with or, and that. Okay, well that took me a long time, but never mind. Let's bring this back over here, and hopefully it'll now match all the rest, and it does. We got some NAs. Does your person have a visible tattoo? Ah, yes, sorry. Have I stuffed up on visible tattoo? Because no. Anyway, so I think the issue there is probably that it's a two-word column. Let's have a look. Let's return CL. What? Am I referring to? Oh, wait. This. What the heck? Okay. Right. I remember now. I never changed this to CL, so that's pointing to God knows where. Okay. Sorry. Okay. Now, how many people have all these attributes? So now we can take what we've done here and hopefully speed things up a little bit. So, I guess I want to say lambda at, and then I want to do that's at, and that's at, that's that. And sorry, except that I don't want the sum there or here. Like I said, I want to get a column of zeros or ones. So let's test that somewhere with a little more space. So we'll come over here for a second. So we'll say all of that madness of, does your person have curly hair? Gives me a string of zeros and ones that sums to 195. That's exactly what I want. So we'll save lambda. I guess I'll call it @2binary. Nice catchy name. All right, now we can clean up all this mess over here. Ooh, can we? Sorry, yeah, I have to fill that up. Okay. All right, so now this can just be sum of @2binary of this times @2binary of this times @2binary of this. No, I don't accept your correction, Solov. But I do need, whoops, I do need one more closing bracket. Okay, level 6. Oh my god, there's still 2 more levels. I should have gone a little faster, I guess. Okay, so which option for the next question will split the group of people with 3 given attributes as evenly as possible? Okay, so you've asked about these 3 attributes, and then the question is which of the next 3 questions will split them up as neatly as possible. So let filt be @2binary of this times at. It's the peril of trying to. I think I could have solved this faster and probably got it done within the 30 minutes, which I probably won't now do if I was not trying to explain. But there, by trying to explain and justify my case, I've ended up making my case look harder than it was. Sad. Anyway, so now we're going to filter TLOOKUP LG hash all, and we're going to look up these things. We're going to filter that by filt. Sorry, another closing bracket. Okay, so in other words, when I get down to the 6, it mentions here in the example, there are 6 people that match all of these, the same as the example in the previous level. So now I've got, if I ask about mustaches, none of them have it. If I ask about glasses, there's 1 yes and a bunch of no's. If I ask here, there's 2 yeses. What I want to do is have yes and no split things as evenly as possible. So we're going to say minus minus that equals yes. We're going to bicol sum that to see how many yeses there are. Then we are going to take sum of filt over 2. So the perfect split would be if it was exactly equal to that. So I'm going to say this is how far away you are from the perfect split as an absolute value. And then finally we're going to XLOOKUP 0 in that absolute deviation from the perfect target, returning from here, and we want exact match or next larger item. And the answer is facial piercing is the best next question. Okay, level 7. How many people match all of these attributes? If no one matches all the attributes, return the first attribute that excludes the last matches. Okay, so I'm going to say reduce I'm going to start with 1,000 ones. I'm going to reduce through these attributes. I'm going to say lambda a. The first thing I'm going to do is, if I hit a point, so the idea is you either say how many people match all of these, or where do you first fail. So to handle that, I'm going to have it take a column of 1,000 things and keep multiplying that by the 1, 0 column for the next attribute. And if at some point that fails, I'm going to return the text. But that means that from then on, I want to carry that on. So I'm going to say if rows of A is equal to 1, then just keep A, because that means that I've come to an attribute. Otherwise, it's going to be let nxt be A times at to binary of V. And then if sum nxt equals 0, that means you've come to the end, which means you want to return text before V before space pipe space, which is the attribute name that you fail on. Otherwise, you want to return nxt. And then I want to say let call it rd. Wait, sorry, that says male. That is not where it's supposed to fail. Bother. Oh, sorry. Yes. Because it's not just an attribute, it's also a yes or a no. So, careful. So I want to do at to binary of text before V before the pipe. And then I want to say I guess I'll say if that, then yes, no. I swear I could have done this in half an hour. I promise. If that, yes, no, and I want that to be equal to text after V space pipe space. Okay. And then I think we carry on. Just need a bracket around this. So, wait, missing a closing here, are we? Add to binary of, yeah, missing a closing here. I close the if, then a closing there, and then we're good. Okay, now it gets a happy expression, which is where it should. Then I'm going to say let rd be this. I'm going to say if rows of rd is greater than 1, then sum of rd, which is how many people do you have left, otherwise rd, which is the value. Okay. All right, so that's the levels. Let's do the bonuses. Who has the most yeses on the small data tab? So we can XLOOKUP. There are only like 10 attributes or something. Let's just XLOOKUP 100 on by row SM equals yes. So let's make it minus minus SM equals yes. Some where are some brackets colored? No, there's not. Never mind. Look up on that, returning from SM name x next exact match or next smaller item. Okay. How many people have the most common hair color on the large data tab? Note, hair color is the second word in the description. There is no color if the person is bald. Okay, so I want to, let's just not, so the hair color, and it does mention, I probably should have mentioned that in the bonus description as well, actually. Oh, sorry, I did. Color is the second word in the description. Hooray. Aren't I clever? Okay, so then I'm going to say text after this space, and yeah, actually that will obligingly get rid of bald, so then I just want to say most of that, and I want to know how many people have the most common color, so that's going to be index 1, 2. Bring that back over here. Okay, 3. Of all the yes/no attributes on the large data tab, which has the highest percent of people with a happy expression? E.g., 20% of people with facial piercings have a happy expression. Which attribute is this the highest for? Okay, so I guess we'll say, so First, I'm going to get a column that will tell me how many people have the desired properties, and we're going to apply this to all of the yes/no columns, which is here. So if I call that, I'm going to say lambda CL, it's going to be countifs. CL is yes, and what did we say? Happy expression? I wasn't really paying attention. Let's go with that for now. It's going to be that divided by the same thing, but without requiring a happy expression. And then I'll go and read the question, and then we'll finish it off. Have a happy expression. Okay, good. And the question was, which has the highest percent of people? Okay, so then we're going to XLOOKUP. These are percentages, so I can just XLOOKUP 1 in that, returning from the corresponding headers, exact match or next smaller item. And we're good. Okay. Each pair of yes/no attributes appears together a certain number of times in the large dataset, e.g. 25 people have a beard and glasses. There are two pairs that appear the smallest number of times, and they have one attribute in common. What is it? This one got a little bit convoluted because I wanted to just ask what pair appears most often together, but then there wasn't just one. Okay, so I'm just going to make a little table here. So I'm going to say if this equals this, then just give 0. Otherwise, countifs tlookup lg hash all. This is yes. Wait, no, didn't I figure out tlookup wouldn't? Never mind. Let's just say sum of tlookup blah, 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 equals yes times this guy. Okay. Right. So then, what are the max? Just highlight top one item. Uh-oh. Uh-oh, uh-oh. That's not good because there were meant to be 2. Okay, I guess I'll go check my old answer. Okay, so attribute number 1, attribute number 2. Lambda AB countifs index large. 0A, yes. Index A, yes. Okay. Let's try to reproduce. hstack at num1 at num2 and cnt. Oops. Go away. Okay, so I've done it by numbers, fine, but so 1 and 2, for instance, appear together 25 times, yes. Did I ask about the most or the least? I asked about the least, because I'm an idiot. Okay, so I want the bottom one. Even when I write the question, I still can't read the question. Yeah, and that's, of course, it's 0, so let's make it that. Okay, now finally we're getting somewhere. So there are 2 things containing 19, and they both contain mustache, so the answer is mustache. Okay, and if the player asked about all 10 yes/no properties and got the worst possible set of answers, meaning the set that matches the greatest number of people, how many would they still have left to choose from? I didn't actually say large, but obviously there is only one data set with 10 yes/no attributes. And this one I can just do most of by row through all of these 10 attributes concat. And the answer is, the worst case would be no's for most things, but yes for, I think, facial expression. 2, 3, 4, yes. 5. Anyway, whatever. No, yes for smiling. Right, sorry, that's facial piercing. Facial expression is not a yes/no category. Anyway, the answer is 80. So we'll say index that 1, 2. All right, so there you go. I'm way over time. I do think I could have done it in the time, but that's hardly the point. I doubt it will bring the people who struggled with this any comfort to know that it was in theory solvable. But yeah, sorry about that. It wasn't meant to be so awkward that you had to just resort to manual, but I can see how there was a pretty big step in difficulty once you got to here. All right, well, that's all I got for today. Thanks for watching. See you next time.